Slicing and indexing are used to access and modify the contents of ND array object. In this video, we will study about indexing arrays, and in particular, we will look at how to index or access values of single dimensional, two dimensional, and three dimensional ND arrays, and the same concept can be extended for higher dimensions as well. So first, let's understand why indexing. So it's used to obtain individual elements of an array or the contents of the ND array, but it can also be used to obtain entire rows, columns, or planes from multi-dimensional arrays. So let's begin a few examples in our Google Colab notebook. So first, let's see 1D array. So we create one array, and first of all, we need to import NumPy. And we will create a NumPy array from a Python list, and let the list contains 10, 5, 20, 25, and 50. And let's also print this array. So first time it's going to take some time. If you have opened the Colab notebook, it will connect and allocate some machine for you. And then we can access the elements using some index. So indices starts from 0. So first element is at index 0, then 1, 2, 3, 4. So here max index is 4. So let's access the first element. So we need to pass ARR10. So this should return 10. Next, let's see how we can access the last index. So one way would be to access it using 4, whatever is the size minus 1. And the other way is to use minus 1. So from beginning, the indices starts from 0 and goes all the way up to size minus 1. So let's print the size also. Size attribute of this array. It should be 5. So indices go from 0 till size minus 1, but there is a reverse indexing also. The last element is indexed minus 1, next one minus 2, minus 3, minus 4, and minus 5. So from minus 1 till minus size. So let's try to index it using that method. ARR1 minus 1. So it should return 50. And it returns 50. So minus 1 denotes the last element. Let's say I want to see the fourth element from the end. That is second element from beginning. So what we will write? ARR1 minus 4. So it should return 5. So it returns 5. And it only prints the last statement. If you want to print both, you should include it in print. In a given cell, this is the limitation of the cell. If you just write the value, only the last value will be printed. But if you write print, everything inside the print will be printed. And but you cannot give arbitrary indices here. So here we were giving valid indices, either positive or negative, but all of these were valid. What happens if I give a index which is more than the size of the array or even the size of the array? So let's see. It will give some error, let's say 100. We know that this array has just 5 elements, so index can be, positive indices can be from 0 to 4, but we are trying to access 100 first element. So it gives index 100 is out of bounds for axis 0 with size 5. So in order to correct that, you can make sure that you always do a modulo with its size. And we had already seen that this size attribute is 5. So modulo 5 will always be a value between 0 and 4. It can never be 5. If it's 5, modulo 5, it becomes 0. So it will lie from 0 to 4. So this will always be a valid index. And in this case, 100 modulo 5 is 0. So it takes the first index. So that's it for 1D array. Let's see some examples of 2D array. So let's name it ARR2. And this time we will create it using a range function. And let's create it 24 values. So it will take values from 0 till 23. And we can additionally chain it with more functions. Let's reshape it to 2 dimensions. And our shape will be 4 cross 6. So 4 rows, and each row will have 6 values in it. Let's print it as well. So this is our 2-dimensional array. There are 4 rows, and each row has 6 values in them. Now let's say I want to access the second row, complete row. So in the case of 1D array, if we pass one index, it returns one value. But in the case of 2D array, each element is itself a row. So when we pass just one index, it will return a complete row. ARR2, and we pass 2. So again, index starts from 0. So 2 denotes third row, that is this row, 12, 13, 14, 15, 16, 17. So let's print it, and we say that 12, 13, 14, 15, 16, 17, this third row is printed. Now let's do the same thing here, negative indices. And what if I do ARR minus 2? So first let's guess the answer. This last row here, minus 1 denotes the last row instead of last value. So minus 1 is this, minus 2 will again return the same thing. 12, 13, 14, 15, 16, 17. And what if I want to access, let's say, this 14 or 20? How can we access it? So this is in the 4th row. So 4th row means first index should be 3. So let's try to fetch that value, 21. 4th row means 3. It starts from 0. And then the value is 4th value. So it will again be 3. So let's make a change here. Let's make it 4. So it should return 22. And it was ARR2. So you see we got 2. So this is how we can get a value. There is another way of getting the same value. Or instead of using 2 separate indices, we can club them together like 3, 4. And still it returns the same thing. So either you pass row and column in separate square brackets, or you can combine them with comma. Both are the ways of accessing this 4th row and 5th column. And let's see some examples of 3D array. So again, we will name it ARR3 and a range. This time we will create 40. So it will contain the values from 0 to 39. And we can add reshape here itself, but let's do it with some other method. So we specify the shape here. It's exactly same as doing reshape in just one line, but we should know different ways of achieving the same thing. And it should print first axis is 2, so it holds two matrices. And what are the shapes of those matrices? The shape of each of these is 4 cross 5. And if you go one level inside into one of those matrices, you will see that it has 4 rows and 5 columns in each of the 2 elements in the first axis. And now let's see what happens if I just add one index. So 1 denotes 2, second value, that is this part, this matrix. So it will exactly return the second matrix. So ARR3 has 3 axes, so we add one index to it. So one axis will reduce. Now it's 2-dimensional. Now let's go one level deep. 1, 2. So this 1, 2 denotes 1 is the second matrix, and here 2 means third row of this matrix. So this should return 30, 31, 32, this row. So let's see. So it returns this third row from the second matrix. Now let's go one level even deeper. ARR 3, 1, 2. So we come here. First we come to second matrix, then third row, and then let's add 2 here. That means third value in this third row, that is 32. And let's see. And it correctly prints that. Now we were accessing here the values, we were not changing the values, but the same thing applies to all of the above examples. We can change the value, modify the value also. And let's get the same value that we accessed earlier and put a value of 555 and then also print it. So you see, this was the place where 32 was sitting. Now 555 is sitting there. So whatever we saw here, all of those apply for modifying the values as well.